Hey everyone, hope you enjoyed this week's video on helping you understand how to safely free memory in C. Let's get started. Imagine that there are a large number of 122 students and staff working in a lab. The lab's rules are simple. They're only allowed to use labeled test tubes. These test tubes all have caps in the beginning, and they're fixed in place on a large rack. In order for a student or a group of students to use a test tube, they must ask the teacher for permission to use one. The teacher then looks for a capped test tube and uncaps it, before giving a student a permission slip indicating the location of their test tube. Each student can work on their test tube and only their test tube however they wish, but when they're done, their group must tell the teacher to put a cap on that student's test tube. Finally, these caps are very reactive. Therefore, any improper use results in an explosion. So how does this have anything to do with freeing memory in C? Here's what each component of this analogy represents. Each block of memory is represented by a test tube. For simplicity, we don't care about the size of the memory represented by each one. Thus, the heap, which is the region of allocated memory, is represented by a long rack where each test tube is at a fixed location. Pointer variables are represented by the students. Pointers themselves, or addresses in memory, are represented by the permission slips that they're granted. This means that aliasing is represented by multiple students using the same test tube. A program is represented by a group of students, while malloc and free are represented by the teacher. And finally, undefined behavior is represented by an explosion. Hopefully, you see how this can represent some important processes in C. Allocating memory happens when a group of students ask the teacher to grant them a test tube, as explained earlier. Accessing memory happens when students pour contents in or out of a test tube, and freeing memory happens when students ask a teacher to cap a test tube, therefore making it available for other students to use. Note that freeing memory does not alter the contents of said memory, but simply makes it available for future use. Using this analogy, we're able to represent some of 122's most important rules for allocating and freeing memory in C. Rule 1. Do not leak memory. You should always free the memory that you allocate. Let's say Emma is finished working, but she and her group forget to tell the teacher to put a cap on her test tube. This represents leaking her unused memory. If Emma's group keeps asking the teacher for more test tubes without ever asking to cap them when they're done, eventually there won't be any test tubes left to give out. Even though Emma's group has plenty of test tubes that they don't need, they won't be able to run experiments anymore. Therefore, memory leaks are bad because your program could eventually run out of memory even if memory is available and then crash. This is why you should always avoid memory leaks and free allocated memory once you're done using it. Next, you shouldn't be using the memory that you've already freed. If Evan were to use memory that has already been freed, that would be like trying to manipulate the contents inside a test tube with a cap on it. Since these caps are extremely reactive,
Wow.
This code illustrates the scenario we just presented. When you use memory that's already been freed, you'll get undefined behavior. This also means that you shouldn't free any memory that you want to use later on. Now onto our last rule for freeing. Don't free the same block of memory twice. Let's say Alex and Rita are in the same group, and they're working together with the same test tube. This directly represents aliasing. In other words, they own and share the same block of memory. When Alex decides that they're finished, as per lab protocol, they ask the teacher to cap their test tube. However, if Alex or Rita later ask the teacher to cap the test tube, even though it's already capped, then
Wow.
Therefore, you should never free the same memory twice. This mistake, which is called a double free or invalid free, also leads to undefined behavior. Here are two code samples that represent the previously described scenario. It's important to realize that they break the same rule. Because of aliasing, calling free twice on the same pointer does the same thing as calling free on two different pointers with the same address. The second scenario is a common mistake we see, but hopefully, you now see why it leads to undefined behavior since you're still freeing the same block of memory. Thanks for making it to the end of the video. We hope that this analogy helps you better understand what you should and shouldn't do when freeing memory in C. If you're having trouble diagnosing your memory errors, please refer to our Valgrind guide on Ditto and check out our Valgrind